Hello, everyone. We are Bloc. My name is Ryan. This is Sophie, Joe, and Christos. So what we've built in the last 2 weeks is a multiplayer isometric building game. You guys probably don't know what that means, but I will tell you a bit of background. So what is isometric? Isometric is a way of representing 3D in 2D, as you can see from that top graphic right there. So 2D, you have a top-down perspective on the left, bottom, Zelda, and there's no depth perception. On the right, Mario, there's no lateral perception. Isometric representations solve that by tilting your game board or your game objects horizontally 45 degrees and forward, let's say around 35 degrees, so you get a top-down perspective. So that's isometric. What is our game idea? We had inspiration from the Legos that Joe brought in. He claims that he doesn't play with them anymore, but... So we decided to go for a simple route. We didn't want to use hefty libraries. We didn't want to use physics engine or anything. So we went for just a simple construction game. But I would rather show you guys and not tell you guys, so here's our demo. Lego? Who even plays Lego anymore? Play Bloc! So there we go. We have a working, fun game. 99 problems with a block ain't one. So I'm going to pass on to Sophie, who'll talk to you about our processes now.
Right. The first thing we did was break our brief, which was to make a multiplayer isometric game down in 3 main sections: an isometric element, a multiplayer element, and a game element. We decided to tackle the problem of how we were actually going to build the isometric shapes, and therefore which isometric library we were going to use first, which we did by gathering together and discussing the advantages and disadvantages of the libraries we knew about. We then went and did further research, which involved actually using some of the features of each library and testing how easily we could manipulate them. We continued to use a similar process for each of the remaining main elements. During the 2 weeks, we would come together to discuss the task we wanted to tackle and then split off into pairs, making sure to swap pairs often in order to keep the team dynamic and fresh. We also made sure to practice good testing development in order to cut down on time wasted by fixing bugs. I'm now going to pass on to Joe, who will talk about the multiplayer aspect.
Thank you, Sophie. Our MVP was to get a single block on a screen, which is actually a lot harder than it sounds. There's a lot of maths involved. But once we had that down, we moved quite quickly to have lots of blocks on the screen. And then we hit our second hurdle, which was multiplayer. So our problem was, essentially, we have 2 machines here. How do we make them talk to each other? You can see Sophie on the left, Ryan on the right here. Sophie clicks a block. Somehow that message has to come across to the other side. So what we have is a message being sent to a third machine, which actually lives in the cloud, probably belonging to Amazon or someone like that. The message is interpreted, something happens, and the message comes back down here. We use WebSockets to solve that. It might sound a bit scary, but it's not at all after 2 weeks. Our code actually ended up moving from the client side, so actually on your machine, in your browser, we actually pushed it all the way up to the top here. So that was some additional complexity, but we overcame that. Christos.
Hi, I'm just going to run through some of the problems that we had when we were designing this application, and Joe will run you through the way we overcame them. So the first main issue was how we would design the application. We introduced quite a lot of new technologies into it, so we were unsure how to structure the program where parts of the program would live. For instance, if the game would live on the server or client side.
Yeah, so our solution to that problem was the diagramming skills, which you saw from an earlier team, which we've honed at Makers Academy. it helped us to understand the message flow, which was actually our key problem. We couldn't see where the messages were going, so producing a diagram for that allowed us to decide where the code should actually live and where the game should really be happening.
Another big problem with when we were designing the application was the maths involved. We realized quite early on that it was quite involved to convert the mouse coordinates to reflect on the grid. So we basically decided how we were going to do this. The rotation of the blocks was also another layer of complexity.
So we spent a lot of time up front on the math stuff, technical challenges. We went back to some of our high school trigonometry, which I think is that thing in the middle. If anyone knows about cosine, please let me know. Still not clear what that is. And we actually went as far as, special credit to Ryan here, we reverse engineered one of the code libraries that we were using to solve our problem. So we sort of modified code that we had, but we knew it was doing something one way, but we needed it to do it the other way. So, so we used that for that.
When the project first began, we had lots of different ideas on how we would go about achieving what we wanted. It soon became apparent that there wasn't much time to implement all of these features. So we had to discuss between ourselves what we wanted to leave in and leave out. So it was quite a struggle to compromise on what we wanted.
So yeah, yet another skill from Makers Academy coming your way. We used user stories to break our problem down into manageable chunks. And it really did help us iterate and increment slowly. And we had a whole list of about 20 crazy ideas, of which virtual reality was one of them. 2 weeks is quite a big ask for that. But it turned out that even with, say, the top 10% of that list, we had a really fun game that just turned out to be great fun to play. So yeah, and here are some creations with our game. Narayan's creation on the left here. Albert and Ryan. I don't know if you want to explain that one to us. And then, yeah, so here's our URLs down the bottom. Please go and make great stuff with our app.